The best game of the last decade has no skill tree, no leveling, and no inventory. You can't lose a single item because you don't have any. The only thing you collect is understanding. That game is Outer Wilds, and it belongs to a design tradition that most indie devs don't know how to build. Knowledge-gated progression. Games where the only thing blocking you is your own understanding. No keys, no XP, no grinding, just do you get it yet? When you finally understand something, the whole game opens up. And here's the critical difference. You can't lose that understanding. It lives in your head, not in your save file. Contrast this with how most games handle progression. Metroid locks doors behind upgrades. Find the morph ball, roll through the tunnel, access the next zone. RPGs lock content behind levels. Grind enough XP, your damage number goes up, you can beat the boss. Both of these are external gates. The game state tracks whether you've earned the right to proceed. Knowledge gating is different. The gate lives entirely in the player's mental model. The game doesn't track whether you understand something. It doesn't need to. If you understand it, you act on it. If you don't, you wonder until you do. Let me make this visceral. Imagine a locked door. Game A puts a key in a chest 3 rooms back. You find the key, walk to the door, press interact, you're through. You didn't learn anything. You performed an errand. Game B has the same door, but there's no key. Instead, the wall next to it has a faint shadow pattern. If you've been paying attention to the cathedral across town, you notice the same pattern there, and you realize the shadow changes position based on the time of day. At noon, the shadow points to a loose brick, behind it a mechanism, pull it, the door opens. Same result, completely different feeling. Finding a key is checking a box. Having an insight is you doing something. That's the emotional core of knowledge gating. There are 4 techniques that make this work. Master them, and you can build a game where progression feels like genuine understanding instead of errand running. Technique 1, the information network. Outer Wilds does this better than anything else ever made. Your spaceship has a computer that tracks everything you've discovered, but it doesn't present discoveries as a linear list. It's a web, a directed graph where every piece of knowledge connects to at least 2 other pieces. You learn that the Nomai built a probe cannon. That node connects to why they built it, which connects to the eye of the universe signal, which connects to the time loop mechanism. Each discovery points forward to what's next and backward to what you might have missed. The design principle here is critical. Never build a linear knowledge chain. If insight A only leads to insight B, which only leads to insight C, you've built a pipeline, not a network. Pipelines break. Miss one link and the player is permanently stuck. Networks have redundancy. Miss one path and there's another way to reach the same understanding. Technique 2. Rule layering. The witness is the master class here. Each area teaches exactly one rule through environmental examples. You solve panels that demonstrate the rule without anyone telling you what it is. The first puzzle in each area is designed so you can solve it by accident. You trace a line, the panel activates, and you didn't even know what you were doing. Then the next puzzle makes the same rule slightly more explicit. By the 3rd or 4th panel, you've deduced the pattern. You own that knowledge because you figured it out yourself. The game never told you. Later areas combine rules you've learned separately. That combination creates new understanding that neither rule produced alone. The design principle: make the first instance of every rule solvable by accident. The player's aha moment comes from recognizing the pattern they were already following, not from being told what to look for. Technique 3. The in-game codex. Tunic hands you the game's instruction manual, page by page, but the manual is written in a constructed language you can't read. You collect pages out of order. Some pages contain diagrams that make sense immediately, others are meaningless until you've seen the thing they're depicting. Andrew Shadis, Tunic's designer, described this as creating content for no one, secrets that don't need to be found by all or any players to be worth including. The knowledge gate works because context transforms meaning. A page showing a shrine with an item on it means nothing when you find it in the first hour. 3 hours later, after you've walked past that exact shrine a dozen times, the page clicks. You go back, you try placing the item, it works. The gate wasn't the item. The gate was connecting the page to the shrine. That connection lives in your head. Technique 4. The deductive chain. Return of the Obra Dinn and Blueprints both use this. The player must build a mental model by cross-referencing multiple independent sources. In Obra Dinn, you determine the fate of 60 crew members by examining death scenes, cross-referencing clothing, rank, location, and who was near whom. Each confirmed fate narrows the possibility space for every remaining unknown. Blueprints layers drafting mechanics on top of deduction. You're building the house while searching it, and clues in one room only make sense in the context of rooms you drafted 3 runs ago. The design principle: every conclusion must be reachable through at least 2 independent paths. Never require one source to solve anything. The player should be able to triangulate the answer from different angles. If they miss one angle, they can still get there. Now here's how to actually build this. 4 steps. Step 1, build the knowledge map before you build a single level. Get a whiteboard or a spreadsheet or a graph tool. Map every piece of information the player needs to learn. Map every location where they can learn it. This is a directed graph, not a checklist. Draw arrows from prerequisites to insights. If an arrow only goes one way and never comes back, that's a dead end. Fix it. Step 2, build redundancy into the graph. Every critical insight needs at least 2 independent paths leading to it. If the player needs to understand that water quenches fire, let them learn it from an NPC who mentions it, from a scroll that describes it, and from a room where fire blocks the path and water sits in a visible pool nearby. 3 paths. Missing any one doesn't matter. Step 3. Order without forcing. The player should feel free to explore in any direction, but the knowledge map should gently push them toward insights in a productive order. Outer Wilds does this by making some locations survivable only with prior knowledge. You can fly to Dark Bramble on your first loop. You'll probably die to the anglerfish. That's not a hard gate. It's a strong suggestion that maybe you should learn about anglerfish behavior before going back. The player never feels railroaded. They feel like they made a smart decision to go somewhere else first. Step 4. Close the confirmation loop fast. When the player has an insight and acts on it, the game must confirm or deny that insight quickly. Nothing kills motivation like thinking, maybe I figured it out, and not knowing for 20 minutes. The confirmation doesn't have to be a pop-up or a text box. It can be a door opening, a new area revealing itself, a sound cue, something that says, yes, you understood correctly. Keep the confirmation loop under 60 seconds, ideally under 30. Here's where most devs screw this up. The number one failure is the single path knowledge chain. Insight C requires Insight B, which requires Insight A. The player misses B because they walk past the room where it's found. Now C is unreachable and they don't know why. They think the game is broken. They quit. Redundancy fixes this. If there's a second path from A to C that doesn't go through B, the player never gets stuck. The second failure is fake difficulty through obscurity. Hiding information isn't knowledge gating. Knowledge gating gives the player all the pieces and asks them to assemble the puzzle. Obscurity hides the pieces and calls it a challenge. If the player can't find the clue, that's a finding problem, not a thinking problem. Different design skill entirely. Make the pieces visible. Make the assembly the challenge. The third failure is no feedback on wrong answers. If the player tries to apply knowledge incorrectly, the game should communicate that it didn't work and ideally hint at why. Silent failure teaches nothing. The player tries something, nothing happens, and they don't know if their idea was wrong or if the interaction just didn't trigger. That's a design bug, not a puzzle. The fourth failure is the wiki problem. If reading a 5-minute guide solves your entire game, your knowledge gates aren't deep enough. The understanding should be experiential. You can tell someone the anglerfish are blind and hunt by sound, and they'll know the fact, but they won't have the visceral memory of drifting through fog in silence, holding their breath, watching the massive shape glide past 2 meters away. That experience is the understanding. The fact is just a fact. Design your gates so the player needs to feel the answer, not just read it. Now here's where AI tools make this dramatically faster. The hardest part of designing knowledge-gated systems is validating the clue network. You need to check for dead ends, single path dependencies, and ordering contradictions. That's graph analysis, and it's exactly what large language models are good at. Feed your clue list into Claude Code and ask it to find every insight that only has one path leading to it. It'll flag them in seconds. What would take a designer days of tracing arrows on a whiteboard takes one prompt. You can also simulate blind playthroughs. Give an AI your puzzle chain and ask it to reason through it without any prior knowledge of the intended solution path. Watch where it gets stuck. Those stuck points are exactly where your real players will get stuck too. This catches roughly 80% of knowledge gate design failures before you ever run a LPATs. And when you need a second path to an insight, AI can suggest where in your existing level design a redundant clue could fit naturally, not random placement that makes sense in the fiction of your world. We're designing and playtesting knowledge-gated progression systems inside AI Craft. with AI tools mapping clue networks and finding dead ends before a single player touches the game. Join the community and build with us. Please feel free to subscribe and check out the links in the description below.